Hey everyone.
Hey everybody.
Welcome welcome to another episode of Eigenbros. Today we have a fellow Eigenket actually.
Indeed.
Yes, and Sahana, and she's actually maybe you can introduce yourself a little bit.
Okay. Yeah, hi, I'm Sahana. I'm an astrophysicist and one of their friends, and excited to be here today and have a fun discussion about astronomy and time and all sorts of crazy stuff.
All kinds of good stuff. So yeah. And
Planet.
Did I say my name actually?
Nah, people know your name, dude. You get
Who are you?
Terence, by the way.
Who's this guy? Yeah. We actually had, we if you want to get salacious, we talked a little bit about planet, some unknown planet in the solar system.
The Nemesis.
Yeah.
Yeah.
Well, it has a lot of code names in the community.
We got a little
but-
conspiratorial.
Yeah, UFOs, that's kind of cool. There's probably going to be a follow-up episode, so look up. I know there's some of you UFO heads
Yeah.
itching for, alien video or something.
Yes,
So,
hopefully you get a little bit of a taste.
yeah. So, but yeah, we had a lot of fun, and we're excited to get her on the next show. But for this one,
Indeed.
go ahead and listen, like, subscribe,
Share.
share.
And then
Share.
Also follow us on Twitter. So that's at Eigenbros, at Eigenbros on Twitter. Then Eigenbros.com is the website. And Sahana also has her she did a podcast with our friends Beyond the Physics. So if you want more of a, another podcast more, that one is, it's Beyond the Physics. You can find them at, Beyond_physics on Twitter.
I'm pretty sure they have a webpage too.
Do they now?
Yeah.
Okay.
Check it out.
So was it BeyondThePhysics.com?
Probably. I don't know. I don't know if Joe has that kind of money to buy domains, but
Yeah, you guys
It's a hard life out here.
check out
Yeah,
Beyond
yeah.
the Physics. Joe and Irene and I had a fun conversation on that podcast.
Did you guys have
too.
wine and cheese too?
Yes.
Oh, nice.
They're so fancy over there.
See,
We're
they're
not
so-
that low.
We're not that. Yeah.
All right, guys. So it's going to be a good episode, and stay tuned.
All right. 3, 2, 1. Hey everyone, welcome
Hello,
To another-
everybody.
to another episode. I guess.
Yes,
Uh,
a special episode today.
Special episode.
Yes.
Actually, more than extraordinary.
We have our
So-
first elegant lady guest.
Yes. Sahana.
Yes, Sahana.
Yeah. So she's an esteemed astronomy student.
Yes.
Yeah, graduate student.
Mhm.
So she's gonna actually tell us a little bit about, I guess, what it means to be an astronomer. Because we were asking that question last time, right? We were
Sure.
like-
Yeah.
I was like, what the hell do astronomers do? Like,
Yeah. It's kind of like it's like, I mean, wouldn't you say, Sahana, like astronomy is kind of a different physics than like a lot of other stuff?
Absolutely, yeah. It's done in a different way, and I feel like astronomers have a very different vibe than a lot of other physicists.
Yeah.
Yeah.
like you guys are a lot cooler than us.
Yeah.
We actually had this.
You're the one who
debate.
said it, not me.
Us
So yes.
us nerdier, yeah, because I feel like there are certain fields that are much more nerdier than others, I think.
Yeah.
I mean, obviously theoretical is that kind of thing, but
Right.
And actually, Sahana was on the Beyond the Physics podcast. So
True.
if you guys
Check
haven't
that out.
seen that one yet, that's our friends as well, Joe and Irene. So you can check out her more in-depth interview there.
Yes.
It's more of a personal one. Ours is kind of more casual. We don't give a damn, goofy. So
Yeah.
like
Excellent.
say whatever. We
Yeah.
can talk about anything here, pretty much.
Yeah, pretty much.
But yeah, it was a good interview. I listened to like half of it.
I wanted to listen to more, but
It was good, and you
'Cause
kind of
he-
went into like some things about being a woman in physics, and then also talking about
aliens and
One of my favorite
yeah.
topics.
yeah.
Oh,
you got
hell yeah, you're
some
in the
cool
right
things
place.
Yeah. We actually did 2 videos on aliens, so
Yeah,
Awesome.
we wish we could do more about it. It's like what is it? They're actually, what was it? The Navy just announced that they publish like actual UFO videos. Did you guys
Yeah,
see
man.
Yeah,
that?
I saw that.
I was
Yeah.
like,
we might
whoa.
have even have to get into it.
And no one cared.
Yeah, no one cared. We're like,
no, you know Michio Kaku?
Yeah.
He actually was like, we actually have some real hard evidence, or some real, what would you say, like real
certified.
I don't want to call it evidence because it's still like the bare minimum of evidence,
Maybe
right? For
compelling
this.
arguments.
Yes, exactly. So he is
Uh-huh.
like we have the first like compelling arguments for UFOs.
And that's like a big deal, I think.
Yeah.
For a physicist
Absolutely.
to say that. And I mean,
Yeah.
Michio Kaku, people make fun of him and say he's kind of off the rails now because he's
Mhm.
talking about fucking, shooting your brain in lasers across space and shit. But
Sex or robots, that kind of thing.
but I mean, he's still there.
Yeah.
He's a physicist. You gotta have crazy ideas sometimes.
Yeah.
So
You got to be crazy to believe that strings like make up the universe.
Yeah.
No, I'm just crazy. I'm kidding. No, but yeah, that was kind of like whoa. Like the community was a little bit like some of the people that follow this stuff were like, this is kind of a big deal that they announced that.
But those crazy people always say that. Like it's
Yeah,
more big a deal
yeah.
when a physicist actually says it.
Yeah. Well, I mean, especially when the
The government.
government says
Yeah.
we really have no clue what this is. Like,
I mean, what do you think about that, Sahana? Do you think it's legit, or do you see anything kind of like? Is there anything that gives you pause?
What gave me pause was that, like, I personally did not see that huge of a reaction. Like, it kind of got swept under the rug after a few days, which I think is kind of telling about, like, the state of public opinion right now. Like, I feel
Right.
like if this was maybe 5-10 years ago, we'd be hearing about it for much longer.
yeah.
Oh, you think?
Yeah. But, like, the fact that it kind of got swept under the rug and the fact that people weren't, like, suddenly like, oh, my God, the Air Force or the U.S. government has suddenly changed their decades-long stance
Yeah.
on UFOs and aliens so quickly
Yeah.
and kind of out of the blue. Like, just the silence around it is what I find interesting.
But did they actually the government claim that it was actually extraterrestrial?
I'm not sure.
They can never say, dude.
I don't
Yeah.
think they can say that.
I think they can just say unidentified.
Okay.
Yeah.
Or, like,
But they just are
unknown
now
origin.
like saying it with a more serious, like this could actually be extraterrestrial.
No, I don't
And
think they
not-
ever say that.
I don't-
Or
yeah,
not
I
even
don't-
saying like it could be.
Maybe. I don't think they could ever use that language. I just think
because then people will just run with that and say, "Oh, they
Yeah.
said it."
Yeah. I think
Yeah.
it's implied by the fact that it's unidentified or unknown origin.
Yeah.
So aliens are a possibility, and like
Okay.
because that is the most exciting possibility, or the fact that we can't really,
Yeah.
if we could trace it to Earth or something like that, then
Yeah.
it wouldn't have unknown origins. So
Right.
Yeah.
that is the sort of the catch-all possibility that is the most exciting and
Yeah.
allows the most room for explanation.
Right.
Yeah.
That makes sense. So I guess the unidentified part kind of already takes care of that. So okay,
Yeah.
fair enough.
Because then, it's kind of nuts.
Yeah, we got people on our comments still asking us to do alien videos. I'm like, guys, I mean, we got a lot of videos to potentially do, but
Yeah.
like specifically the Bob Lazar one. We did a video on Bob Lazar. Do you know him?
Most popular video.
Sahana.
So
You're about to
Go
you're gonna have
down
to
the
go down
rabbit hole.
now.
Oh, gladly.
Yeah, so Bob Lazar is this dude who apparently worked at Area 51, and he's a physicist who apparently graduated from MIT and Caltech. That's a very big air quotes, though, because the evidence around that is very nil. Like, they don't have any records of him being there. But, just to say that, but he has one of the more compelling stories about UFOs, and he goes on Joe Rogan's podcast, and it's like an hour-long plus podcast, and he talks about the entire facility, and like they were working on this alien aircraft potentially, and it was a gravity manipulation craft. So he was saying that you could look inside of it, and there was a dome, like a crystal ball kind of dome, and when you would try to touch it, you could not touch it because it had antimatter, or it had a repulsion for massive objects. And he kind of went on and talked and actually described the technology of these aircraft. So it's like one of the more interesting alien interview or alien accounts, because it's from an actual physicist. We did a whole 2 videos on it. And
Yeah.
I'm gonna have to check that out.
yeah, but we kind of we'll let you check it
Yeah.
out. But people keep asking for follow-ups for it and
Yeah.
things like that on the actual. Bob Lazar has another video where he talks more in depth about the technology. But I don't know. I'll tell you, me and Juan kind of settled more towards his bunk. But of course, you should look at it yourself, because it is very
Yeah.
compelling. Like, you need to
Yeah.
actually have a good analysis to be
Yeah.
able to say whether or not
Yeah.
it is.
Yeah.
I'm surprised you didn't hear of it. It's really
He's like a
you got to
plumber
look it
for
up.
me.
Yeah, that's why I feel like there's a lot of stuff out there about like actual alien like accounts
Yeah.
in the U.S. I don't really know about.
Mhm.
I'm more like I feel like my point of view of aliens is more from an astronomy point of view, in that I'm someone who looks out in the cosmos and I'm constantly asking what is out there.
Mm-hmm.
Yeah.
So it's very natural to also ask who is out there.
Yeah.
And
Right,
as
right.
astronomers,
Yeah.
a lot of like the public opinion is kind of like finding aliens as part of our job and part of our field.
Yep.
And so how do I deal with questions like that? And as an astronomer, like, yeah, I would be super excited if we found aliens.
Yeah.
And aliens are definitely a compelling, like, unknown discovery out there that we're all secretly chasing.
So Hannah, the question for you is then, if you could build, let's say you've got this massive, ludicrous budget. If you could make your own like alien detection agency, like how would you do it?
Good question. I think if we want to find aliens within our lifetimes, like on a human time scale, because one of the biggest obstacles, in my opinion, on finding aliens is the fact that we as humans have not gone that far out into space. We haven't even made it out of the local neighborhood
Yeah.
within our galaxy. And
Sure.
our galaxy is huge. So
Yeah.
yeah, there might be aliens out there, but part of the issue for humans is that we want to meet them. We want to have evidence. We want to have contact.
Yeah.
And right now we just don't have the technological capability to go across those large swaths of space.
Yeah.
So I would definitely say, like, first we got to figure out like faster modes of transport, and I would not have the alien communication like operations based on Earth. I would want them to be kind of scattered in space around Earth and kind of like a network working with each other too.
So like a network of satellites.
Satellites are like space stations. You said hella
Okay.
big budget, so I'm gonna build.
going big.
I'm gonna
Alright.
build
Yeah,
space
yeah.
stations.
Yeah.
All right, fair enough.
Yeah, and put them everywhere. Because also, like, you know, it would be a very exciting, like, you know, existential thing to make contact and hope that they're friendly. But you also have to consider the fact that they might not be friendly,
Exactly.
because humans are not always friendly.
Right.
Yeah.
So I think
We've heard
that's
the Pocahontas story way too many times.
Oh yeah,
Yeah,
yeah. We do that on Earth, so there's no
Yeah.
reason we won't do it in space.
Exactly. Or they're going to do it to us.
Exactly.
They're gonna be like,
No, please.
Yeah, that's why I think a network is like just, you know, coverage all around is a smarter way to do it. That way, if one side gets attacked, you don't lose the whole operation.
Okay.
And that way you get input from all the different sides that are working on it. Because, you know, if we're going to do this, you need input from people all over the world. It can't just be like, you know, one or two
US.
countries.
Yeah, of
US,
course.
yeah.
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 Yeah. That's one thing that's really cool about astronomy. Sana, we were actually even talking about this a little bit before. Like, it's just so. And actually, you talked about this on Joe's podcast too, where astronomy is like, it's such a social physics. You have to really work with a lot of different people from all over the world. It's like you can't really be isolated in it.
Absolutely. And I think one thing that is important to note is, like, especially for people who live in the U.S. or have grown up in the U.S., especially like people our age or even our parents' generation, like the after effects of like the 1960s, like space race is
Yeah.
still culturally a huge part of the U.S. like psyche, and like why NASA is still considered really cool, even though they keep slashing their budget.
Yeah.
But the U.S.
Elon's
is,
taking over though.
yeah, the U.S. is not the only country that has made strides in space. And
Yeah.
in fact, you know, things like
India
like,
just.
that's what I was going to say. I was about to
freaking-
plug India.
Yeah.
So ISRO's done an amazing job. So they are the only country to launch an orbiter to Mars on their very first try.
Damn.
Yes.
Okay. Nice.
Every other
Props.
country has blown up a ton of stuff before they could do it. India did it one, which is very exciting. They also just launched a lunar orbiter, launched a little rover there. And the fact that India has been able to make these giant strides in their space program within the span of a few decades, when it took the U.S. like maybe 50, 60 years to do so,
Yeah.
is very impressive. And they do it in a much more cost-effective way.
Really?
Yes.
Okay.
It
Nice.
all costs
So
less
it's a
money and it
complete
works better.
evolution in a sense.
Yeah.
Okay,
Yeah. And the
nice.
speed in which it happened, I think, is super notable.
Sure.
And so ISRO is also launching a bunch of communication satellites to improve telecommunications within India. And they're just developing a lot of really cool technology at a really fast pace.
Dang.
And I think when I speak with like my American classmates and stuff, not a lot of people know that. We're still watching for Elon Musk to keep like sending shit up into
Right,
space. Like,
right.
oh, he launched his car, and it's like, all right, who cares? Like,
Yeah.
ISRO just did things that are way more like complicated and qualified and cool, and that are gonna improve
Yeah.
technology around the Earth.
Right.
We also have like the Japanese space programs, and the Chinese have also built a lot of really impressive technology over the last few decades.
Mm-hmm.
And if you look at something like the International Space Station, even though from a U.S. point of view we see it as, oh, we have all these like U.S. astronauts that go into space, that's so cool, they're astronauts, but it really is a multi-country effort, and there are entire modules that are built by other countries. The U.S. had to rely upon other countries' space programs to take our astronauts up after the space shuttle program was decommissioned because we did not have our own astronaut transport capabilities. And so it's things like that about how outer space is so big and astronomy is such a large effort, and we're just humans. We have to work with people around the world in order to do it. And I think that's part of why I said astronomers have a different vibe. It's because a lot of what we do has to cross international boundaries. And when you do that within a collaborative field like science, it kind of changes the way that you do science, because it's less about necessarily how you communicate, but what you're communicating, and being willing to put aside things like cultural or political differences to work together to this larger goal.
Right. Yeah. That's such a beautiful thing about science is like it literally transcends everything almost. It's just like, you're a human, I'm a human. Do you know how to do some shit? Then you're cool.
Yeah, you're both curious.
You know, it's like, we're both on the same page then. So yeah, that's why I love science.
It's cool. It's like I feel like astronomy might be one of those disciplines where you kind of have to be more sociable in a way. I think we were talking about this. Yeah. Like, because I think back to my undergrad astronomy professor, and he was like a regular dude. He was like very easy to talk to. Yeah. More like, I hate to say it, but more human in a way. But it's like something difficult to find inside of a traditional like physics department. Yeah. And it's like, wow, that's cool.
And when Juan says physics, he means a non-astro. So like what we do is condense matter, and then there's other branches of physics like high energy. There's I guess what particle physics would be the same as high energy?
Yeah.
Okay.
I mean, I'd put them adjacent.
Yeah. Okay, yeah. Nuclear physics. So yeah, there's different regimes in physics. There is some arbitrary cutoff.
Yeah.
But it's like, it's just a nice way to kind of keep people who are doing similar things together.
And let's talk about that, the arbitrary cutoff, because I was always like, my department was physics and astronomy, and I'm like, I mean, astronomy is physics, right? Like, why put a cutoff here? Like, no, this is physics. Is it because they're like, those guys are way too cool to be physics? They're too normal.
Maybe nowadays.
What?
They have lives? What? No. Like, what would you say about that?
I would say, like, that's true. A lot of universities do have separate physics and astronomy departments, or astronomy is often a standalone subject, like a cousin of physics. And I think a lot of that has to do with the history of astronomy. So people have been looking at the stars for all of human history, and we've built up lore, and astronomy kind of started first with people looking at the stars, noticing the patterns, and then over time recording those patterns in different cultures around the world, figured out different astronomical phenomenon, like how to count the days, the seasons, eclipses, all of that stuff. So the fact that it has such very, like, I guess, ancient non-science roots, and the fact that people pursue astronomy out of curiosity about something that we all see as humans is very different from physics, where even though most people, we are ruled by the physical forces, but most people are not wondering like, oh, what's up with neutrinos? But a lot of people do look up at the moon and wonder what's up there, what is it made out of? And so also, like, when we think about the history of astronomy in academia, so I would say if you think about maybe the 1800s or so, when there's a lot of like academic institutions popping up, or back in the day, that's when astronomers would get telescopes, go look at stuff, or even Galileo's times, he'd draw out everything. And so the way that astronomy was done in the past like couple hundred years in Western academia is different than how physics was necessarily done.
Right.
And so I think that's part of why those subjects are often different. And also the way that they're studied and the resources that you need for astronomy versus physics are different. And so I think it's kind of mainly a historical divide that kind of keeps going on to this day. And like,
so then actually it sounds like we've kind of had even more of a convergence then.
Yeah.
Because back then it sounds like people kind of you could get away with doing astronomy with not necessarily knowing so much math and physics, right?
Yeah.
So now it's kind of like they're like, oh, these things are completely like they're all relevant. So they've kind of converged a little bit in like, a U shape, I guess.
Yeah, I agree completely, especially with nowadays we have things like nuclear astrophysics.
Yeah.
Or we have people with particle accelerators and lab equipment that try to figure out like what kind of atomic physics or nuclear physics is going on in outer space, and we compare what we see in the lab to what astronomers see in telescopes. So I agree that there are definitely places where they're starting to come together, especially now that astronomy has gone from here's what we see out there to how do we explain what's out there. It definitely connects with physics more and requires input from other areas of physics to be able to explain all the different astronomical phenomena.
So it's sort of like y'all are experimentalists in the sense that like, but it's funny that they still create a distinction, because like experimentalists within like say condensed matter, right? They don't
they don't
call
say
it a whole
condensed
different
matter.
thing. Like it's like, no, I mean we're still part of condensed matter, and it's split into subgroups, theory and experimental. So where would you see astronomy fit in any, say if you could merge, say if you wanted to consolidate like terminology and save space or something, and what would you put astronomy in nowadays, or where would you categorize it nowadays in most traditional like departments and like?
I mean, I think astrophysics is a good way of putting it, just because now if you go through an undergraduate or graduate astronomy program, you don't just learn, okay, here's Kepler's laws, here are the planets, all that stuff. You also learn about things like stellar dynamics, which are dictated by things like radiation transport and like
all right, dumb it down a little bit.
All right, sorry. So they're basically like dictated by the different forces that's happening within stars and how these forces balance each other out over time, and that's physics.
Yeah.
And those forces also exist outside of stars; they exist here on Earth and stuff. And so you learn more about the why from the very beginning, not just memorizing what's out there.
Yeah.
So I think it really is becoming more astrophysics than astronomy. But like within astronomy, we do have slightly different terminology. So what I do, I use telescopes to take data. So we are observational astronomy. So that's like the astronomy side of experimentalists, because we can't control, we can't set up an experiment. We just have to look and wait for what we want to show up, or look and be like, whoa, what is this?
Right.
So there's observers, but there are still theorists who start from like first principles, or start from like, okay, there's this idea, let's try to model an object with some equations or with some sort of model, and then go from there, and then we compare that to observation.
And typically the astronomer theorists use a lot of programming, yes?
Yes.
Okay.
Yes, theorists and computational astrophysicists do a lot of programming.
Now, do you know anything about that side? Like how high of a level do you need to know programming to do that kind of stuff?
I will say the programming that's often used is very specialized. So it's there are specific programming languages and like sort of software packages that have been developed to perform certain modeling or computational things. So it's kind of like getting to know a specific piece of equipment in the lab. Similar thing for a lot of theoretical and computational astrophysicists is you get to know this one package of software really well that someone else has written, and then you use it based on what you want to know. So there are people who are like developing new software. That's a whole other section of the field. As computer technology improves and stuff, and as we move away from older programming languages, a lot of this software is being adapted for the next generation of computational models. So it's a fair amount of programming. I think if you can do that, you will probably have the skill set, or at least the ability to learn the skill set to work in like tech or something like that.
Right.
But it's
so you
not,
can potentially get a job afterward.
Yes,
That's good.
Yes, I think you can definitely get a job afterwards. But no, it's not the exact same coding as like Google might want.
Yeah.
Okay.
So if you're going to be a theorist, do some coding.
Yes.
If the things don't pan out in academia, at least you can get a job at the end.
Oh yeah. No one does like pen and paper calculations that much anymore. It's all on the computer.
Yeah. So speaking of models and stuff, Planet 9. Have you heard of this mysterious planet from
Pluto?
No. People are saying there's a sort of like dark planet that is in our. It's
Nemesis.
Something like that. Yeah.
Oh, it's even got a.
It's got a bunch of names like
what's it called? spooky name.
It's got a bunch of
Oh, yeah.
names. I think if I'm correct me if I'm wrong, but there's a lot of sort of not conspiracy, but there's like an underground sort of science kind of group that's a little bit
Underground science already sounds sketchy.
well, no, because they have a sort of idea that there's a big giant exoplanet orbiting our solar system.
Okay.
It doesn't necessarily that can kind of answer certain questions we still have within our solar system because there's
Why?
certain
Because it has some gravity signature?
I don't know. I mean, I think the argument. Maybe you can attest to this.
So
This is out of my
if we're
realm.
talking about the same thing, so I have also heard this theory of where it's a theory that there's this dark planet, possibly a brown dwarf, like a star that didn't quite get hot or dense enough to start like nuclear fusion and actually start burning. So
Yeah.
it's just this dark, dense clump of gas that is not quite a planet, not quite a star, just this zombie
Yeah.
cycling through our solar system. And one of the reasons why people think it might exist is because we have cyclical mass extinctions here on Earth based off the fossil record. So one theory is that, all right, this dark mass comes and passes through our inner solar system once every however many hundred of millions of years.
Yeah.
And because it comes through, what it does is it'll gravitationally attract asteroids closer to Earth than they normally would. So that causes asteroids to come hit Earth and cause these mass extinction events on a cyclical basis.
Very interesting. So
Yeah.
it's just a credible theory.
Well, there's a recent video, but I forget the YouTube channel. I think it was
Truth something?
Veritasium. No, it was
Veritasium?
Veritasium.
Okay.
Yeah. He was asking, people about this, and of course, what he gave both sides of the argument. One guy thinks that it might be legitimate. In fact, he gives a sort of list of what questions it would answer that we have about our solar system, and like you're saying, it sort of it attests to certain like human kind of anthropological history of disasters and stuff. But among other things, there's a lot of other scientific like reasonings why this planet would exist. But yeah, it's like it's. I thought you might know a little bit about this, but it's also very interesting because modeling is heavily used for that.
Yeah.
And that's one of the ways that the guy in this group that's working on it is very. They're relying heavily on the models to kind of give them the data because they can't really observe it. They're not going to be able to observe it. They're trying to figure out how they can observe something like that. So
Yeah.
because and this is something I kind of wanted to ask you actually. How would you be able to observe something like that if it's outside of our solar system in the dark almost, right? Like it's like finding not even a needle in a haystack. It's even probably worse than that.
Yeah.
Yeah.
Like how the hell? I don't know. I right. What would you do? How can you do
Yeah.
that? How could you approach that?
Yeah, that's a good question. I mean, what I would guess is first, like, we don't know that it's dark. We just think it's dark because we haven't seen it.
Yeah.
It could have a super eccentric orbit that's really, really stretched out and long. So it just travels in a very, very, like, sort of thin, like, oblong orbit. So it just comes in and comes out as it goes. And there is precedent for that. Like, Pluto's orbit crosses Neptune's orbit. So there are objects that that haven't cleared their own orbit, as we say.
Yeah.
It's not the main thing that's traveling basically on that pathway around the sun. It could also be that its orbit is just really, really, really huge. And what we've been looking for in the last, say, 50 years or so just has not come back into our neighborhood. Maybe it's going to take another 3,000 years to come back.
Jesus.
Maybe it's there. We just are looking for it at the wrong time.
Maybe when you see it, it's too late.
Yeah, exactly.
Yeah, because
Yeah.
it's
It's like that Fifth Element thing. You remember that giant sun? Do you remember that?
no.
He used to communicate with the sun. Zod
Fifth
or whatever
Element?
his name. Yeah.
I don't remember.
The guy, what's the guy who always is in every movie?
Bruce Willis.
No, but he's a really good actor that you don't know who he is. It's he's the guy who played Commissioner Gordon in Batman.
Oh, that
yeah,
dude.
Gary
gotcha.
Oldman.
There we go.
Yeah,
Sure.
he used to communicate with the guy in space, and he would make his head bleed.
Oh,
You don't remember
okay.
that?
No.
No.
I
You
haven't
guys
seen that.
gotta
I haven't
rewatch
seen
it.
that movie in a long
I haven't
time.
seen it in a while.
It's a great movie, but yeah.
Yeah. Anyway,
You're like, it's like that. Okay, so what does that guy communicate with
he
the?
communicates with the Nemesis.
Oh, so you're saying this
Remember
planet,
when he communicated with
the
them,
planet.
he was going to come destroy the Earth.
Oh.
Because the fifth element got unleashed.
Okay.
So
Well,
I'm saying that guy is Nemesis.
communicating with the planet, and
Yeah.
well, yeah, it's super interesting. I wonder even if something like that exists. So we obviously we don't have all the answers for like what's going on in our solar system, right? Even
Right.
then, you would think, oh, we've discovered a couple planets, but there's still a lot of questions, right? Off the top of your head, do you know what the most recent sort of big discovery you could say that's like, like this was kind of a recent answer that might surprise you or something? Like,
I think the discovery of Kuiper belt objects and trans-Neptunian objects is very exciting. So what that is out beyond the orbit of Neptune, out where Pluto is. I think this was theorized first in the 60s by a physicist named Jan Oort, that there is this...
Oh, the
like,
Oort cloud.
Oort cloud,
Okay,
yeah.
yeah.
That the Oort cloud is out there, and this is thought to be the origin of many comets that come into our solar system. And the Oort cloud was theorized for a very long time, but we didn't have observational evidence really for it until we sent probes out there, and like the New Horizons spacecraft, which went and took that amazing photo of Pluto.
Pluto, yeah.
Because that's past. Is that in the Kuiper belt now?
Yeah, it's going through there now.
Is it taking images?
Yes, it's detecting other objects. I don't know what it's done most recently since it's passed by through there, but it's definitely.
But it's like still operational, everything.
I believe so.
Okay.
And
That's
Voyager
cool.
is out there too. Voyager 1 and 2 made it
Yeah.
out there too. So kind of looking at this, what we think could be the edge of our solar system. Because even though we have an idea of what that boundary is, when you start looking at the boundary, it gets a little fuzzy. And so being able to confirm the thing like an Oort cloud, and that we can use the orbits of objects as they come into our inner solar system to figure out where they're going outside the solar system.
interesting. Okay.
Is pretty cool. And there are like Kuiper belt objects and trans-Neptunian objects that are bigger than Pluto.
Oh wow.
So there are several ones. I think there's one called
That's
Haumea.
why Pluto got demoted, right?
Part of why it got
Yeah.
demoted. Yeah, it's a dwarf planet now. Found things like Haumea that is much bigger. And so there are these larger bodies, and based on following their orbits, it's like, all right, are they fully gravitationally bound to the sun? Are they moving around the sun the way the Earth is? Or are they just stuck in between two larger bodies? Are they doing their own thing? So I think investigating these outer reaches of our solar system and discovering that there are a lot of bigger stuff out there
Yeah.
Right.
is really exciting and really cool, and
Yeah.
something to keep an eye on in the next few years.
Yeah, because like it kind of blew my mind that the sort of the Oort cloud, or the sort of the
Kuiper belt.
yeah, it was this asteroid belt was kind of a recent sort of experimentally verified, I think.
Yeah, I
right?
didn't realize
Yeah.
that either. I thought
Yeah.
we just knew about that forever. I was like,
Yeah.
oh, okay.
Yeah, no, it was theoretically predicted. We just didn't have the technological capability to go
Yeah.
and see it
Right.
until very recently.
It's nuts.
It's kind of like the whole black hole thing. Like everybody's like, "Oh, we've known about black holes forever." You see all
Yeah.
these
Oh,
renderings
that
and things.
was
Like I've seen
exciting.
black holes all the time. Like no, these are all artist renderings.
Yeah,
Like
Yeah.
oh, okay.
Yeah.
yeah,
So-
that was another spectacular.
Yeah, that was
Um,
nuts.
Yeah,
Yeah.
achievement. And
Yeah.
I'd also like to ask or add, I think that the New Horizons or the Event Horizon Telescope, to obtain the black hole picture, is a really good example of how astronomy needs to be an international collaborative effort. Like,
Because they made a giant telescope essentially, right?
yeah,
Yeah.
They connected, I believe, 8 telescopes across the world with the baseline, kind of like it's like using a telescope with the diameter of the Earth.
Yeah.
Yeah.
To obtain this imagery, and it involved like a high level of collaboration between people who speak very different languages, very different backgrounds, and who operate in very different countries to come together, pool their money and resources together to pull it off.
That's awesome.
And I thought the way that they announced it was really cool too, because they did kind of a rolling press release across the Earth, where each of the different home teams, announced the photo and the results to their own home country, and so they were able to put out this press release in many different languages, which is
Nice.
very exciting. It doesn't always happen.
Yeah. Yeah.
But also, it was just like a message that traveled around the world, and I thought it was a very exciting and collaborative way to make scientific announcements instead of just doing it like once, 9 a.m.
Yeah.
Eastern Standard Time.
Right,
Like,
right.
Yeah.
Yeah.
Yeah, that's cool. I didn't even think about that.
Yeah.
Yeah, I think I watched it live because everybody was saying it's going to be a picture of the black hole, and then I looked at it, I was like, that's it.
Yeah.
I was like, that's actually really a big achievement. But it's
It
like,
is.
it's just funny because it's like this built up thing, and then it's just like a little pixelated image.
Yeah. Yeah.
But there was so much going on in that one image. It was just like really impressive once you actually start to break down, and it was, of course, confirming all of Einstein's everything once again, and
Yeah, and the fact that we can now observe regimes that are not light observations. So what I mean by that is most of what we see in astronomy is because we're receiving light from outer space. But there are objects such as black holes that suck in all the light, so the light can't escape, so we can't see it. So things like this Event Horizon telescope photo where we could see the surface of the black hole based on what's around it, and things like gravitational waves finally allow us to look at places without light, which we've never been able to do before, and is going to open up a whole new set of physics and astronomy.
That's
right.
cool. Damn.
Well, here's the thing, though, with gravitational waves, though, they're still going to be limited by that hard speed limit of light.
Yes.
So we're never going to be able to see anything past, since the Big Bang. But that is still pretty cool. I was trying to think, I was like, is that going to let us see things that we cannot see with light? But then I was like, it's still going to be bound by the speed limit. So I don't know, is it actually going to shed any new information?
I think it's going to shed new information on compact objects. So compact objects are objects like white dwarfs, neutron stars, and black holes that are very, very dense. And so some exciting versions of those are things like pulsars, which spin really fast, or magnetars. And so these are objects that are very dynamic or sometimes very easily detectable, like pulsars, because they shoot off these high rapid beams, and so we can figure out the distances to them, but how they're created isn't fully well understood. And so as we saw recently with the neutron star merger, that type of merger will release gravitational waves and is the source of things like our process elements, which are heavy metals. Everyone was really excited about all the gold and platinum it's created and stuff. But things like that, like, where do these heavy elements come from? And we can finally see it. And so being able to understand the origins and dynamics of compact objects is very important, because those are the kind of objects that create elements and drive evolution, basically. And by evolution, I mean, they say, how do galaxies form over time? How do stars and planets form over time? So it really affects the evolution of...
So like cosmic evolution.
Cosmic evolution. There we go.
Okay, yeah.
Yeah.
We've had a biologist on here several times. He's all talking about biological evolution. So I just want to make that distinct for viewers.
Cosmic evolution.
Cosmic evolution,
Yeah. That's interesting.
Dang. So what you mentioned magnetar, right? What magnetars? What type of Pokemon is that?
Ooh.
No, I'm just kidding.
But
I had to.
he's here all night, folks. He's here all night.
No, yeah, it's so cool. Like I was teaching my nephew about like astronomy, and like it's so profound. Like, thinking about like the origins of life are with the stars, right? You have to really that's really what it is, and it's like it's sort of a natural LSD moment that you have with nature,
It's a great way to put it.
Yeah, it's like, wow, I came
the
from
stars, man.
Yeah.
Very existential,
Yeah. I imagine. Do you feel? I feel like physicists in like office settings have to kind of stick their heads in books more often than looking at the stars and everything. I feel like. Do you feel like you have more of a connection with the universe in a way, or your profession? I mean, it's probably you. Do you feel a deeper connection like with your job in that way?
Yeah, I mean, I pursue astronomy because I love it, and it's something that I've always just had this innate like motivation for. I don't really know what it is, but it's always interests me, and I know that's just the direction that I want to move in. One thing I will say about astronomy that like a lot of my friends and family that I've talked to about this, they're just like, it's so big. Like, don't you feel so like small compared to the size of the universe? And it's like, yeah, we are small and insignificant in comparison with the size of the universe. But for me, like the way that I would describe it is, I know about the sun. If I go near the sun's going to kill me, but the sun doesn't necessarily know about me. So kind of the knowledge and trying to gain understanding about these really big, exciting things out there is what makes astronomy very exciting for me. And like, it makes me feel good knowing that, even if we just like completely fuck up Earth, which we're not going to get into that, but you know,
Yeah,
that
we
is
did
an
episode on
issue.
climate change. So
Yeah, I don't know. It gives me peace as a human to think I will never fuck up more than this local environment, and the rest of space is going to be fine. Like stars are going
Oh,
to
I
keep
see.
burning, the galaxy's
Yeah,
going to
yeah.
keep going, cool shit's going
Right.
to keep happening.
Yeah.
Like it's okay. We will never mess up enough.
right, the universe is not going to give a fuck about us.
Exactly,
Like, at
yeah.
the end of the day.
Yeah, it's all going to be okay.
Yeah.
You know, don't sweat it.
Right.
Yeah. Or
Now-
unless planet Nemesis comes and is like, I'll finish the job for you guys.
Yeah, but I mean, that's bad for us. It might be
Yeah.
okay for Nemesis. Nemesis is probably like, hell yeah, lunch.
I'm just doing my job.
Nemesis is actually like a giant, like cosmic whale.
yeah.
Yeah.
Yeah, man, it's that's I always try to see like, because I imagine because right now I think humanity doesn't appreciate the fact that there's sort of a light show going on up here that we don't even we're so removed from our connection, and I feel like that's a connection with the universe like right away that you can experience. Like, when was the last time like you went out to see the stars and it's just like, wow?
Actually, it was kind of recent.
Okay.
Just because there was that meteor shower. You
Yeah.
remember the meteor shower? There was
Was
supposed
that
to be
in August?
some impressive meteor shower. I was falling asleep the whole time. So unfortunately, I didn't see much. I mean, I think I saw like 4 meteorites. I wish I would have had like a telescope or something. But I only had some cameras. I was trying to get video, and of course, that doesn't work either.
You need
So-
a wide aperture.
You got to do a long exposure so you get the streaks.
Yeah, exactly. So I was in complete amateur hour, and I was just falling asleep. But I was like, damn, I really should have thought about this more. But that was the last time I looked
Yeah.
at the stars, and I could actually see them.
Yeah.
So
Like I had the one moment I had. This was before I actually got into physics, but like I was out in like West Texas, in the middle of nowhere, and we were like in a camp. We were camping out, and I hadn't seen. I'm a city boy, so like I had no fucking idea.
Yeah.
I thought that shit that they showed you on CBS, you know, for like nature, like cosmos stuff. I was like, that's all like CGI stuff. you know,
or
that's
like
not
some
real.
really high tech photography where they
Yeah.
like do long exposure
Exactly.
and all that kind of stuff.
I was like,
yeah.
oh, I've seen Photoshop. It's cool, but
yeah.
anyway, like I was like, oh, you know, when you look up at the sky in the city, it's just like a couple stars, and you're like, oh, that's kind of cool. But when I went out there and like really I just laid my head back and I was like, wow,
This is like real.
holy shit. Like I immediately had like, it was like a sort of a high
Yeah.
that I got from it. It was like just looking at.
It's actually unbelievable because you can even see the
Yeah.
Milky Way. And
Exactly.
you're like, what? You're
No.
like, I didn't even think I
Yeah.
could really see that.
No, exactly. And just seeing that, I was like, wow, that's like millions and billions of
Yeah.
like planets and solar systems or whatever.
Other
just
galaxies, too.
galaxies, like all there. And it blew my mind, and it really like, it was kind of a spiritual moment. It's weird. Like, but yeah, it's like, I feel like we're totally robbed of that nowadays. Like,
Yeah, I mean, that's definitely something that's come around with modern human life. is
Yeah.
As our days are no longer dictated by day and night or the cycle of the
Yeah,
sun, and
yeah.
we have, lights and everything. You know, we see the stars a little bit less. And, like, even though I'm one who, like, does look at the stars a lot, like, one of the most exciting things that I've experienced in the last few years is traveling to the southern hemisphere and, like, confronting the fact that they have completely different stars than we do. The northern hemisphere and southern hemisphere see different constellations.
right. Yeah.
And that was really exciting because for me, when I like travel across, let's say, the continental U.S., the sky is always a source of comfort because I'm like, all right, I can always figure out where north is, or like this is a familiar territory that comes with me everywhere. But when I went to Australia, it was completely different, and they're like completely different constellations. The kids that grow up there, they have the Southern Cross as opposed to the Big Dipper as their
Right.
guidance.
That's
towards-
cool.
Yeah,
Yeah,
and
I
so
didn't
it's
think about that.
yeah, and that's something we don't really think about, even though constellations and stars are very much a part of our culture in many ways.
Yeah.
I'm so used to just seeing Orion. Okay, got it.
Yeah.
Yeah.
Dipper,
Yeah.
got it. All right.
Yeah.
Yeah, we kinda
That's so
take-
crazy. Yeah, if I didn't see that in the sky, now I'm thinking, I'm like, yeah, that'd be very confusing.
Yeah, and actually from the southern hemisphere, so Orion's kind of there, but he's not a constellation because we're looking at the stars from a slightly different angle. So here we're used to him just, his shoulders, his belt, his knees. He's like
that belt
upright.
is so distinct.
Yeah,
it's like
exactly.
You can pick it,
really
out of
is.
a lineup.
Yeah, he's upright. He's ready to go. But if you look at him from the southern hemisphere, he's a little more stretched out, and his dagger, which normally hangs below his belt, is actually like up in his chest, like he's getting stabbed by it. And so the stars are actually even just traveling
Just rotated a little
south.
bit.
Yeah,
Yeah,
because we're
interesting.
looking at those stars at a different
Yeah.
angle.
That's
Right.
Damn, that's crazy.
Yeah.
I don't think I've ever. I just realized I've never seen a constellation any different than what I've seen. 'Cause I've never been outside the U.S.
Yeah.
So
Dang, me either. Now that I thought about it, I'm like, wow, just seeing a whole different sky.
Yeah.
It's like,
it just shows you how
Mind-boggling.
limited just how limited we are as humans, how
Yeah.
localized we are as beings. It's like
yeah.
just even within our own Earth, like you
Yeah.
can just move to or go to a different part of the country and you're just in a
Yeah.
or a different continent. You're in a completely new world.
Yeah, and I do this professionally, and even I was just like, oh my God.
Yeah.
But it's like naturally humbling though. It's really
Absolutely.
cool. Like I feel like the world needs that sometimes.
Yeah.
Like just
Yeah.
like whoa, like like I've been actually thinking like why I'm not gonna name names, but like why doesn't our I guess what's a better way to put it? How feasible do you think it is for anyone to really start like an astronomy group, like an amateur astronomy group?
I think it's pretty feasible. So many communities have like astronomy clubs. Our community has one, and basically all you need is like find a park somewhere with a clearing that's safe that you can meet up in at night. You need maybe 1 or 2 telescopes, or you don't even need telescopes. You can even just meet and look at the constellations, find out about the history of them, why they're named that way, the myths associated with them. And if you, like, another cool thing that I think local astronomy groups can do is, like, if you go once a month, you'll see changes in the sky as Earth goes around its orbit. So you'll be able to actually see the passage of time and see how our sky changes slowly over the course of the year. Really,
Right.
it just takes a group of people who want to meet together at night and make the effort to go and look and learn about what they're looking at.
Right. Astronomy is very accessible.
It
You
is.
can get a
it
lot
is.
out of it without having to do any physics with it, right?
Yeah.
You can just
It's just all there, right there.
Yeah.
the most fun parts are.
Yes,
Yeah.
yes, and that's the gateway to it that we all get. And I think
Exactly.
like even like astronomy is something you can appreciate even if you're not a hardcore scientist or an astronomer. That's one of my favorite things about it, is that everyone can derive some type of joy from astronomy, and even that little bit of joy is like totally worth it. And no one should ever be shamed for only just thinking, oh, the stars are pretty, because they are pretty.
Yeah.
Yeah,
So-
I feel like immediately like embarrassed when I tell people what I do. Like if they're asking me, "Oh, what do you do, physicist?" I'm like, they're like, "Okay, get that." But then like, "What do you do in physics?" And I'm like, "Condensed matter." And they're like,
Okay.
Yeah. They're like, what are you
"Like
talking
that's a
about?
fancy word for solids and liquids."
And then they're even more confused. Like,
Why would you study solids and liquids?
Yeah. So it's just like a rabbit hole of just like, what the fuck?
Yeah. No, I was thinking like fuck, I'm blanking on it now that I think I'm just like let me see, where was I? What were you saying?
I was talking about condensed matter and
No,
the
about
saying-
accessibility of astronomy.
yes.
okay.
Yes, I
Yeah.
lost the train of thought.
Damn.
actually.
Okay. Well, anyway.
I didn't have coffee today,
Oh.
so like,
Well, we should talk about some time. We're at 47 minutes here.
Yeah,
let's,
yeah.
Let's talk about time.
Oh,
So,
yeah.
Oh yeah,
Sahana-
actually it does have to do with time.
Oh, let's
Oh
go.
hell yeah, let's
go.
go.
Okay. Well, this is my transition. See, I was gonna get to this,
Oh, there
but
you
fuck, I just had a brain fart. So, speaking of time, in this sort of like natural cycle that arises from being an astronomer, do you find that there are more night owls in the profession?
Ooh.
Sometimes, actually, no, not entirely.
Yeah.
I think because astronomy, you've got the observers,
Yeah,
you've got
the
the theorists,
observer,
but
yeah.
not all observers actually operate the telescopes. So I am one of those night owls that operates the telescopes. But
Yeah.
not everyone does. So I think a lot of people start out as night owls when they're younger, but over time they're like, nah, we'll leave that to the
Yeah.
grad students to
Yeah.
stay up all night.
Yeah. Fuck all that.
Yeah.
And so nowadays, like, just in my experience with like professors and researchers, it's easier to not be a night owl in astronomy because we have technology that takes care of stuff while
I
we
see.
sleep.
Cool. Yeah. Yeah, because I was like, I feel like I have this night owl gene in me that it's just like I'm
Same.
just like, dude, I wish I could go to bed at a reasonable hour.
Nope, that's why I work at night.
Yeah, same. And yeah, it's super fascinating because I was thinking like, well, I'm like part Native American, and some of that Native American is from the basically the Mexican sort of peninsula, where there's like Aztecs and the Mayans, and they have a rich history of like looking at the stars,
Right.
and stuff. And they build their greatest legacy was building a calendar and telling
The
time.
Mayans, right?
Yeah, and like if you want to look at the history of timelines, like the Mayans and the Aztecs were like separated by time, like a considerable amount of time, I believe. But they believe that the same people still inhabited the region, so there was just like the rise and fall of civilization. So their legacy was trying to map the stars, and then this, in a way, we're mapping time, and like so. This is a natural segue to whatever Terence wants to say about.
Oh,
time
well,
here.
I didn't have anything in particular, but I guess what I was just thinking of was, just time itself is an interesting subject. So, I mean, you can explore that many ways. But I guess one thing that has to kind of do with time and astronomy was, I remember you even mentioning this at one point, Juan, where you were saying, like, it's kind of interesting how astronomy is like this thing that only exists in a blip of time. Because it's almost like with light, we all know light has this cosmic speed limit, right? So after a certain amount of time, there's going to be no light left to observe. So astronomy has actually it's got a time limit to it, in a sense. And the further we keep going in time, you're actually losing that light. You might see in one instance of time, tomorrow a certain galaxy could not be in our view anymore, or several galaxies. I don't really know how the details, but this is a real thing. Have you ever thought about that, and how you're kind of in an interesting spot in life?
Absolutely, yeah. So a lot of astronomers make the distinction of, we talk about the observable universe instead of just the universe, so the 13.8 billion light year sort of radius that we can see.
And it's supposed to be like 90 billion or something, right?
In theory, but we can't see it.
Right.
So I don't know.
Jeez.
But there might be more out there, but we are limited by what we can see. And the other cool thing, so a phrase that's commonly used is, the further away you look in space, the further back in time you're looking. So if we're looking at a galaxy that's 200 million light years away, when we receive that image here on Earth today, what we see is what the galaxy looked like 200 million years ago.
Right.
So that's often actually how we study the historical expansion, or just the history of the universe. Is as we look further out, we look further back in time and try to reconstruct what happens from there.
That's so cool. It's like you're literally looking at snapshots of history all the time.
Yes.
It's kind of freaky.
It is.
It is.
It is freaky.
Yeah.
And that's why time is one of my favorite things to delve into an existential crisis about.
Yeah.
Because what does it mean, and why do we care if things happen at the same time or not? And I wanted to ask you two about time, because I feel like as physicists, we have a different understanding of time than a lot of non-physicists do, because the way that we're often taught physics is, first you start with a static system, no time dependence. You're given, okay, here are a bunch of particles, calculate the forces between them at a certain instance in time. Then once you understand the basics of that system, then we always add time in. We never really jump into the time dependent part from the beginning.
Yeah.
Right.
Because as things change over time, it gets more and more complicated. So for us, time is a parameter, not an observable, and yet it's still an integral part of how we describe things like motion, how we interact with what we're studying with. Often you have to do experiments for a certain amount of time, and we kind of take that for granted. But also, we're human beings, and time is a huge part of our lives. And at least for me, I feel like I've aged since I entered grad school, but that's me taking a certain amount
Probably
of time.
more rapidly than normal.
Yeah. Assigning
for all of us.
and assigning a meaning to it. Or, you think about, okay, does 20 minutes on the telescope for me feels very different from 20 minutes watching a TV episode.
Yeah.
They are physically the same amount of time, but they are completely separate entities to me.
That's very interesting. That was actually one of my questions too, the perception of time.
Mm-hmm.
Have you also noticed, so have you also noticed that like you have different perceptions of time as when you were younger compared to when you're older? So like when you were a kid, I remember summer vacation felt like literally like it was like, when are we ever going back to school? I don't know if we're ever going back to school.
Yeah.
And then now it's like summer vacation feels like, oh God, it only was this short. You know, it's like it feels like it's already over.
Yeah, that has to do with the pi model of aging. Have you heard about that?
No, I haven't.
No, what is this?
So when you're 1,
Yeah.
you have the whole pie, right? Your
Yeah,
whole life
yeah,
is
yeah.
that 1 year.
Yeah.
But then when you're 2, you know, those are 2 big slices of pie
Yeah.
right there. But then when you get to 10, you're like, oh, you know, I've lived 1/10 of my life.
Mm-hmm.
Okay, this is I'm kind of like seasoned now.
Mm-hmm.
So as you get older, those segments of time, like time is much more segmented and like the passage of time feels much less significant
Mm-hmm.
than it did because you have so many years behind you in
Right.
time. Like it's so strange, but yeah, it's like it's a very psychological thing.
Mm-hmm.
Now, let me add to that. So
Mhm.
I've noticed, I think, a way to almost hack that perception of time, though.
Mhm.
I think I figured out somewhat of a way. I've noticed that I feel like there's a longevity to my time frame
Mhm.
when I'm doing more interesting things more times. I feel like I get locked into a speeding or like a really quick effect when I'm doing the same thing over and over again. Because it's like, I think it's a thing in your brain where since it doesn't feel like there's a distinction between the days, it's like they might as well just be the same day,
Yeah.
you know? And I feel like, you know, when I do a lot of new things or if I'm doing, you know, something I'm not comfortable with and I do it often, then I feel like it stretches out my perception of time.
Yeah.
So I think maybe that's also a key part of it is when you're older, you've done everything.
Yeah.
So when you do a lot of stuff,
Nothing is really novel.
nothing is new or novel.
Yeah,
So I feel like I'm constantly chasing novelty.
Mhm.
And I do it with music, I do it with everything. So it's like I feel like, you know, if I can keep thinking of new things, if I keep doing new things, and I have more of a longevity to my perception of time.
Mhm.
I think you bring up an interesting point that, so for us here as humans, we're living on Earth, time is like a constant thing that's passing. We all agree on how long a second is, and you know, our days feel longer or shorter based on what we've done. And so we have this like inherent assumption or understanding that time plods along at a constant pace. But as physicists, we know that is not entirely true. Like we have like relativistic like
Right.
phenomenon in
Yeah.
which
Time literally exists. It's
yeah.
different in every, you know, dimension.
it's different
Space.
dimensions, different sort of parts of a system will experience time differently.
Mm-hmm.
And for me as a physicist, like I said, those are still 2 kind of separate things. Even though they're physically the same thing, time from a physics point of view is very different from time that I experience as a temporal being whose life is sort of dictated by time and who has a finite amount of time to live my life.
Right.
And it's like trying to figure out where do those 2 merge is just like kind of an existential crisis I love diving into, because you think about it like, all right, if I'm like, you know, marking out time, what is happening in between like my hand marking each second? We can define it in terms of motion, but that's still, you know, saying, all right, my hand moves up and down in this span of time, but you know, that's a recursive definition. What is time in its essence?
Mm-hmm.
Now, I think there is no time. So I've had this conversation with a buddy of mine where I think there is no time if you don't have any change. So I think literally if there's nothing changing, that means that time increment does not exist. I think you can only have time when energy exists. So something has to be happening to have time.
But can't you have a system that's static or like has
And
a
you can
constant
still give that a
energy?
time?
Yeah.
Yeah, but nothing would be changing. Like that would
Yeah,
be
so
kind of
it's-
arbitrary though. But
Yeah. I think
Yeah.
it's like you can assign a time to it, but I don't know if it actually has any real meaning.
Yes. I
So-
agree with
Yeah.
that. So assigning time is part of what time is, and that, we have to say, all right, we're starting this now, and then we're ending this now, and in between is the time has passed. And so we can define the edges of it.
Right.
But still, that doesn't tell us what exactly are we measuring.
Right. So maybe you can even do some weird thinking and say that time didn't exist in that moment when nothing was changing.
Yeah.
Yeah, you
So-
could define it in that way.
Like
Yeah.
if the universe was static, there would be nothing. There would be
I
There
think
would
we
be
consider
nothing.
it no time.
no time.
Yeah.
There would be nothing. It's like the action. It's this whole thing. There's a philosophy of physics that tries to study this kind of concept of time, and like we look at like units. So if you go to, there are certain principles that we try to follow that helps us solve problems. For instance, like the principle of least action, right? And I think that one. And what we mean by action in physics is like energy. If you look at the units, it's energy times time, and that's
You wanna
always
go
been
to action?
confusing. but this is why.
Action's so deep, it's like still eludes me to understand.
Yeah, but that's what I mean. Like it's very like a lot of the time we brush these things off and just do the calculations and just move on. But there are actual like philosophy of physics people trying to tackle these concepts. And it's like, what is time, right?
Right.
And
Do you remember we spent like 2 hours just debating action before?
Yeah, we did.
So
But
that's why I'm a little scared to go down that
Oh,
road.
I'm not gonna
'cause
go
I
down that
feel like I
road.
still don't get.
I'm not
what
going to go
action
down that
is.
road, but it has to do. It's almost fundamental because if you look at like a unit like h bar, right?
Yeah.
It has units of action. Like it's energy times time.
You're scaring me.
It is kind of nuts. It is nuts, but if you look at, but people have played with this concept. For instance, there's a movie with what's his name, Jared Leto. That has
Joker?
The new Joker.
Yeah. Well, yeah. No, he's the old Joker now because
Oh, he's the
Joaquin
old Joker.
Phoenix
Yeah.
is
Yeah,
the new
that's
Joker.
true. That's true.
By the way, the movie looks sick. Yeah. Have you seen the trailer?
Yeah, but I'm
Yeah.
not gonna watch it.
You're not? How come?
I don't know. I'm just like the movie looks dumb to me.
You
I'm
think?
just- I think it does.
It might be cool.
It might be cool. I'll watch it when it comes.
It's got
out.
Joaquin Phoenix. He's a crazy bastard, so I want to see
He's
it.
a great actor. I loved him in Signs, by the way. Signs is underrated.
Sign was a little bit goofy though, man.
Signs is underrated, man.
Dude,
Have
they
you seen
couldn't
Signs?
open the doors though. Everybody
Underrated.
This is the most. It's like if they can't open doors and then they're like allergic to water. That's kind of.
What if they're aliens that don't have thumbs, man? Have you considered that?
if they can figure out interstellar travel, they can figure out how to open the goddamn door. Okay?
Well, if their thumbs
Not
can't,
necessarily.
they're like, "What is this? How do
Can't-
they open
can't
this?"
grab things.
Yeah, can't grab
that is
things.
just goofy. That's fun.
Hey, that's evolution, man. You don't know where it takes you, man. But it is dumb that they landed on a planet that's 90 something.
Yeah, exactly. And they're
a
afraid
high
of
percent
water. Come on.
Yeah. I
You
mean,
gotta
it's,
add drama
can't get
somehow,
behind-
right?
Yeah,
I can't get behind.
it's
it.
an allegory, man, for the aliens are demons, but we'll get into it.
Anyway, yeah. We're on time, right?
Yeah. But yeah, the units for that are the movie with Jared Leto. Yeah. This movie actually, it's really cool because I'm gonna spoil it. Spoiler alert.
Which one?
That's
It's
fine.
on Netflix. It's
Wait, what's it called?
I don't know.
Okay, that's all right. I'm probably not gonna.
If
watch
you know
it.
what it is, comment. Put
is
it
it
on the
Mr.
comment.
Nobody?
Yes.
Okay, I have seen
Have
that.
you seen that one?
Yes,
Okay.
yes.
Okay. Yeah. Okay. Do you want? Maybe you're the guest. Can you like recap us?
What's
what
your
it-
point?
No, the movie. The movie
What point are you
synopsis
talking-
is.
Oh, she would know from the movie.
Yeah, she knows from the movie.
Okay. I'm like, how is she gonna know your point?
Yeah, I don't know.
She's
your
seen the
point.
movie.
Okay, if I remember correctly,
Yeah.
it's like this guy who is it reincarnation or he has like different alternate lives?
Something like that.
Yeah, it's basically like it's like based on certain events in his life could have taken different
Yeah.
trajectories.
Yeah.
And
So it's getting into many worlds now.
But it's time. But it also deals with time.
Yeah.
So at
Okay.
the end of the movie, the trajectory. He's like an old man, or no, the movie's being told by an old man, and then at the end you learn, he's like, all those possibilities convert. I think if I remember correctly,
Converge
it's
to
like-
the same point.
Yeah, and he's like, oh, time is sort of.
An illusion or something.
Yeah, I mean, it wasn't like a mind-blowing revelation, but what was cool was that at the end of the movie, the clock turns back.
Oh.
So at that moment, like
that's
universe,
kind of cool.
the universe goes backwards, and now the movie is told in reverse. So
Right.
he's like, there's no distinction between this time
Right.
and the reverse time.
Also, that's how they added a new element now showing that the symmetry of time.
Yeah.
Where the arrow of time is, you can have, well, not all systems though.
Yeah.
Some systems have a symmetry of time.
Yeah.
But then others don't. The classic example they say is like, I was just watching something Leonard Susskind, he said, Humpty Dumpty falls off the wall. That arrow of time is not not reversible because the particles of Humpty Dumpty are not going to just assemble back and then put it back together. That's going to require a lot of effort and energy.
Yeah.
It can be done, but the likelihood is very small, and it's going to take a very difficult system to do that. But then something like a billiard ball, you can literally play that in reverse, and that is a completely reversible system that makes sense.
Yeah.
So that's an interesting element.
It is. It was cool. But yeah, that deals with like, time reversibility in certain systems, like you're saying. And
I was actually thinking of another interesting thing. I don't know if you've guys seen, my headphones are all messed up. I don't know if you guys saw, there was an article about entropy being reversed in a little experiment. So somebody was doing a quantum experiment.
Oh, I think
and then they
I read
found a
about this.
way to make it so that energy decreased in a localized region. And of course, then you know what happens. People on Twitter and Facebook start putting up,
Law of thermodynamics, like, no.
No, they're putting up even worse than that, saying like, we have time travel as possible now.
Oh, okay. They took that jump. All right.
Yeah. Like the comedian Bert Kreischer puts it on his page and says, I knew it. Time travel is possible. Bert Kreischer is the guy who was the machine.
The machine.
Yeah, he went to FSU, has his shirt off all the time now.
Yeah.
But he put that up there, and then I was like, no. The thing is, like, the only way that would make sense is if you want time travel, I guess, in that sense, that would mean that literally every single part of the universe would also have to turn back entropically, I guess.
It also means causality has to be reversible.
Right. So, yeah, you'd have to violate causality somehow, probably. But I think, in theory, if you could maybe reverse every single process of the universe, then time travel would be possible.
Mm-hmm.
But like a local reversal is not time travel. I guess you could just, I don't know, I guess you could consider it a weird version of time travel in a local region or something. But non-locally, I think if you want to have real time travel, every single thing in the universe would have to be reversed in that instant as well.
Yeah, or I think like when people get very excited about time travel, there's this implication that, okay, like I am the traveler. I messed up something yesterday. I'm going to go back the day before and be able to redo it with the knowledge of the first pass through.
Right.
And stuff. So it's like a Groundhog Day situation type thing.
Yeah.
And I think, in theory, if we could reset time and go back, but maintaining that information is something that we assume we want it to happen, we assume it might happen, but that's not really a part of time reversal on a
now that is violating something probably.
Yeah.
So if you want a complete time travel, it'd be like you'd have to undo everything. So even like those neuronal pathways that were formed once you knew those information bits would have to be undone too. So it's almost like pointless to undo it. Or I guess maybe you could accidentally do the right thing.
But then then you have to boil down to, okay, what is the smallest reaction, or what is the smallest sort of interaction like perceivable or that can exist in the universe that you have to undo to be able to go back in time.
And the funny thing about the perception of time and like stuff like that, we're so like we kind of consider ourselves in a way, at least I do, independent of time. Like I'm an observer of time. I don't partake in it in a way. Like you know what I'm saying?
You got to get a little bit deep with it.
So when I look at a clock, I don't have an internal, I have an internal clock, but I don't have a clock that knows every time I know what time it is. I don't. Like I have to look at the time. I have to observe time to really sort of get an idea.
Okay, so you
of what's
don't intrinsically have a sense of time. Well, you kind of do though.
Your biological clock does. Like you're like, okay, it's time to eat.
It's just like it's like a coarse sense of time. Like a clock would be a fine-tuned sense of time.
Yes.
Yours is like a coarse sense, but I still say
but it's
you
still
have an
based
intrinsic...
on. But it's still based on your own like biological mechanisms that are just kind of like, you know what I mean? Like I don't know if you would feel. I personally don't feel tied to like time because I'm like I could kind of eat whenever I want. I don't have to eat when I'm like breakfast or whatever.
But it's still like, that's what I'm saying. It's still like a coarse measurement of time.
Sure.
because like you're gonna feel hungry probably around the same time.
Yeah.
You know,
but
so
if you maintain a schedule, like you know what I mean. But if somebody like me, like I feel like I'm asynchronous. Like I don't.
Like you can't sit there and go, all right, that's been 3 minutes. Like is that
yeah,
what you mean?
yeah.
But your body might inherently know that. Okay, you usually eat every, let's say, just an arbitrary number of 8 hours or something, right?
Yeah, but you would already put it on a schedule.
Like but no, let's say if you're off a schedule too, and then your body's going to be hungry another 8 hours later, and you might not realize it's 8 hours, but it could be around 8 hours time frame. So you're still on some kind of clock.
Sure, but I mean, like you could always say, "Nah, I'm not going to eat" or something. You know, I'm just saying.
I see what you're saying, but I'm not really buying it. Like you're still tied to a sense of time. Like
sure.
Are you meaning that you are not aware of your time, like being tied to time, like in
Yeah,
your thought process, like? Time is not really a huge factor, or like you as a conscious being, like, even though your body might send you signals, you might have external signals. Like you can't sit there and like estimate how much time has passed since you sat down.
I have a bad sense of time.
But that's also, you're talking about also ascribing a number to it then. You could say like, oh, maybe you don't know how much time has passed, but you definitely know the difference between 5 hours and
But I'm
10
saying
minutes.
it's like you're doing a quantitative, like if
no, I think
there's no quantitative.
That's what I'm saying.
No, I know, but I'm saying like you don't have a built-in quantitative like clock.
But that
in your
still
head.
doesn't mean that you don't have a sense of time.
You have a sense of time, but like I feel like there's no. People don't necessarily, at least for me. Maybe I'm just projecting, but like I
don't know how you're interpreting it though, because I think you do have a sense of time. I mean, you can clearly tell the difference between 10 minutes and 5 hours.
Sure.
I think you two are talking about slightly different things. I think Terence is saying that like you still experience time, so that gives you like an idea of the time scale. Whereas I think Juan's saying that like it's not like you don't have a timer in your head, or rather that your experience of time does not necessarily pertain to the same time scales all the time.
Right.
Like, one day...
time does not pertain to the same time scales.
Yeah, so like you said, the example of like 10 minutes versus 5 hours, 10 minutes on, like, let's say one day you haven't eaten a lot of breakfast, so 10 minutes on the treadmill is going to feel really different than 5 hours walking around like Disneyland or something.
Yeah.
But let's say the next day you have like a really good breakfast, you have lots of sleep, lots of energy, even though those 10 minutes on the treadmill and 5 minutes at Disneyland are technically the same amount of time, to him and his internal clock, they're going to feel completely different. So he's going to be like, that can't be the same amount of time.
Yeah.
Okay.
Like when you sit in a lecture.
I'll give you that a little bit, but I think it still goes with what I'm saying, because I think that's still...
Well, yeah, the experience of time is an important part of that.
Yeah, you have kind of a, there's like a wiggle room. Like you can tell the difference between, like, let's say several minutes. You may not be able to tell or you can tell the difference between minutes and hours, let's say. But you may not be able to tell the difference between 5 minutes and 15 minutes, let's say. But that's just because your internal clock is not as fine-tuned as a actual clock. Well, you have a coarse measurement of time.
Yeah. Well, to be fair, they've done experiments with this. They've thrown people like in a dark room, I guess, or in a room, like not knowing
time
how.
Scales, though?
I don't remember, but maybe we can reference it at some later point.
I would be skeptical if they would be hours, like if it would be like an hour versus 10 minutes difference. If someone was in there for 10 minutes and said, "Oh, I was in there for an hour," or if I was in there for an hour and said 10 minutes, I'd be very shocked.
It was apparently a shocking result. That's all I got to say. It was like, because they're trying to see, like, do we have an intrinsic sense of like time and stuff?
And the conclusion was no.
I can't remember the conclusion, but I remember walking away being like, "Oh, okay."
Okay.
So
well, if you got to find it next time, because I would be shocked actually.
Okay. But all I'm going to say is that.
But I guess it makes sense, because maybe if you don't have external stimuli to keep a reference, so we actually kind of take it for granted because we have a reference with the sun. We have our hunger, I guess you could say even. We have a lot of different references. We have people that come into our lives, and we know what times they kind of come in. So those could be biases. So I like that setup, because if you're in a room with, let's say, a sensory deprivation tank, I actually have heard people say like, "Oh, it just was like, oh, that's how long I was in there," and maybe it is like you may not be able to tell the minutes between hours.
Yeah.
So maybe you could be right. There is no internal.
But that's what I'm saying. Like it to me, my relationship with time is very, like, I don't have a sense of time. There's certain cultures that also don't put a lot of emphasis on time. Like there are cultures that are very strict about time, and like
Germany.
Yeah. I wasn't gonna say it, but no, I'm just kidding. But yeah, it's like So for me, it feels like I'm an observer of time. I don't really live in it in a way.
Mm-hmm.
But at the same time, we do have a physical. I mean, Einstein's equations show that our physical bodies are affected by time in a sense that, like, we're thinking, and it kind of blows my mind because if there's a planet somewhere, Earth like 55 or something, orbiting some sun and some other galaxy or whatever, and their gravitational pull is such that their time scales are operating in a much faster clock than ours. So they're thinking faster. They're thinking like, you know what I mean? Like, we're over here thinking super slow. Like, it's just like,
I always feel that about like chipmunks and squirrels. It's like,
what?
I'm like, they're so fast. Like, I wonder how their brains are going too. Like, even though they may have smaller brains, it's like, they're probably thinking about things faster than us though. So maybe not. Maybe they aren't as smart as us. But I wonder how fast they're actually thinking about stuff.
Yeah.
I've always been curious about that because it's like they're not smarter than us, but they might think faster than us.
Right.
So maybe it's like, is the speed of thought actually a good metric for how smart something is?
That's
maybe not.
Point. Yeah, I don't know.
So
they do experiments with elephants like that too.
Oh yeah.
Yeah, but I don't know. I can't remember. Once again, I can't remember.
Yeah, we'll have to be better prepared.
These are just coming off the top.
Yeah.
So
we're getting at an hour 15 here.
All right.
I know. But
I mean, we'd love to talk some more, Sahana, but I know you got things to do too. You're a busy lady.
Yeah.
So.
But this was fun. If you want to talk again about aliens in time, I'm
definitely.
Yeah,
100%.
We got to be more prepared though. We're gonna have to like really shell out the conspiracy for you.
Yeah, I'm gonna
I'm gonna do my homework next time too.
Yeah. Good stuff.
Yeah, I did like delve into a weird Wikipedia rabbit hole the other week, but maybe we'll save that for the next show.
On aliens?
Okay. Oh hell.
Or do you not even want to tease it yet?
So I recently learned about HARP and like this conspiracy theory about hurricanes. Just with like Hurricane Dorian recently, everyone's like, "Oh, that's HARP. That's HARP."
That's
and
funny.
It was
there you go.
bonkers. I enjoyed 2 hours.
Yeah, some of these are very entertaining.
Your advisor would probably say lost.
Insane stuff. Yeah.
Oh hell yeah. Okay, we can get into it later. But thank you so much for coming on.
Yeah, thanks for having me.
Appreciate it.
And stay tuned for the outro, guys.
Yes.
You guys did it again.
Y'all survived this episode. Thank you for the true fans.
Was this an hour and 15?
I don't know, but probably. Yeah, it makes sense.
You guys are beautiful.
We clearly can't tell time.
Yeah, we can't. I can't tell time.
Exactly.
I'm temporally challenged, and so
So yeah.
But yeah, thanks for listening, and make sure to do everything we requested in the beginning, which is like, comment, subscribe,
share.
Not the singer, share the thing, share the link.
And the Twitter at Eigenbros and Eigenbros.com. And yeah, guys.
And more importantly, check out our guest episode on Beyond Physics. It was a really good episode.
That's Sahana's episode.
Yeah, check it out. I guess, off the top of your head, real quick, I know this is kind of an extension, but like, summarize, I guess if you could remember like a little summary of what that kind of conversation was like.
Beyond
Physics. Yeah, so I had a good time talking with Joe and Irene about being a woman in physics, being a woman of color in astrophysics, and kind of some of the social issues that the astronomy community has faced over the last few years. We also delve real deep into aliens and the philosophical topics of aliens. So if this wasn't enough alien talk for you today, definitely check that out. We do it for like an hour.
Hell yeah.
There you go.
Okay, see, there you go. So check that out, and thanks for listening.
See you guys.
Peace.
I don't know what that means, to play us out. What does that mean? To end the show? To end the show? To end the show? To end the show?